Good morning, fourth graders. I hope everyone is doing well. Today is Wednesday, April 22nd, and it's Mrs. Culp here with you to teach you math lesson 7-9, which is about generating and identifying patterns. Our goal today is to be able to generate and analyze patterns in rectangular numbers specifically. If we look at our agenda, I'll go over our goal again. Right now, I need you to make sure you have some scrap paper and pencil, and any work that you do on it, you're going to want to keep, because we will be starting some of the problems that you will then finish on your own when completing today's math Google form. So you'll want to have your work that we started to help you with finishing those very same problems. You don't want to throw it out or lose it and then have to redo it when you're going to complete that Google form. So again, make sure you have some scrap paper and pencil right now and hold on to it for the Google form because you'll need it to help you finish those problems. Then we're going to start by reading and trying to solve the math message. We'll go over the answer. After that, I'll introduce you to rectangular numbers, what they are, look for patterns in them. We'll even move on to then finding a rule for finding rectangular numbers, which you'll use when solving problems on the journal page. Hint, hint, pay attention to that rule. Then the sixth thing we'll do today during this lesson is practice finding rectangular numbers and analyzing patterns together. And that's when we'll start some of the problems on the journal page that you'll be finishing on the Google form on your own. Then you'll complete, after the video, you'll complete the 4-22 April 22nd math Google form. Like I said, we will get started with some of the problems that you will find on that Google form. So you'll really just be finishing them up. After that, you'll have your extra math fact practice. And then tomorrow you'll come back to look at the home link for today's lesson on a Google form. So don't forget when you're doing that, if you need to come back and watch this video again or go over it, you are more than able to do so. And again, I'm here for any questions if you have them today or tomorrow, as well as the other fourth grade teachers. Like I said, our goal for today is to be able to generate and analyze patterns specifically in rectangular numbers. We're going to do it by watching this video. We'll see some examples, try some, and then you'll be completing the Google form to show your understanding. Why? Well, we need to be able to recognize rectangular numbers, what they are. It helps us to better understand how to generate patterns and better able to analyze them when we are faced with any type of problem, everyday problem that might involve patterns. So our math message for today, it says, use centimeter cubes to build the following arrays: 1 by 2, 2 by 3, 3 by 4, and then be prepared to discuss any patterns you notice. Now, I know you might not have place value blocks, so I'm going to do this here. You may also draw these arrays on paper. So if you'd like to go ahead, you could hit pause right now, draw a 1 by 2 array, a 2 by 3 array, a 3 by 4 array, or get creative, and even if you have Lego blocks, hit pause and do that. Once you have solved it, then go ahead and hit play. All right, hopefully by now you've paused it, you've tried doing that, and hopefully during it you remembered to look at this here. Just a little reminder about that, what an array would look like. An array is that arrangement of objects in a rectangular pattern, usually in rows and columns, okay? An array is a rectangular array unless otherwise specified. So just a little bit reminder about arrays there. If we're going to go ahead and make a 1 by 2, a 2 by 3, and 3 by 4, and then come back and discuss any of the patterns that you notice. So while you were doing that, I opened up the eToolkit, which you are more than welcome to also use. If you log into your ConnectEd account and then go to the toolkit, you can use it too. And then I actually selected on eTools. If you open that up, I selected base 10 blocks, okay? Once you're here, we want to go ahead and, like I said, it shows you here that we want to make a 1 by 2, and then a 2 by 3, and a 3 by 4 array. So to make that 1 by 2 array, I'm going to need to get 2, there's 1, so it's 1 tall, and it needs to be 1 by 2 wide. So I have my 1 by 2 array here, do the best I can to match these up. And then the next one was a 2 by 3 array. So to save some time, I saw this trick here. If I select 2, and I plop them here, and then I highlight them together and hit the plus sign, it automatically conjoins them in a column for me. So if I'm going to make a 2 by 3 array, it's going to be 2 tall. Now I need to make it 3 wide. So I'm going to need to do that again. Add this here. Now I have a 2 by 2 array, and again I'm trying to make a 2 by 3 array though right now. So then I'm going to need to do it a third time. And now I have a 2 by 3 array. So to review, I have my 1 by 2 array here, 1 tall, 2 wide, and then 2 by 3 array. And now lastly, I need to make a 3 by 4 array. So it needs to be 3 tall. So I'm going to change this to 3. And again, a little trick here to make it a little quicker. There's 3, highlight them, plus sign, combines them to one column. And if I need to make a 3 by 4 array, I'm going to need to do it for a total of 4 times. So there's 1, here's 2, here's a third, because now I have a 3 by 2 array. Now I have a 3 by 3 array. When I do that, I notice it forms a square. That's because that's a square number, something we'll touch on in a little bit here. And I need to do it a 4th time to make it a 3 by 4 array. There we go. So it's 3 tall there, 4 wide. Okay? And what I did here is, I had done this before, so I'm going to show you them. And we're going to start to talk about what patterns we notice here, but that's how you would build those arrays. So if I come back to our slideshow here, what patterns do you notice about the arrays that we just made in that math message there? Okay, when you notice these, look at these arrays here, I look at them, I notice they form a shape of a rectangle. So hopefully that's one pattern you noticed, that the arrays here are all 3 are the shape, make the shape of a rectangle. Each array has an even number of cubes. If I look at this first array, it has a total of 2 cubes. 2 is an even number. This array here is a total of 6 cubes, which is an even number. And this array here, the 3 by 4 array, has a total of 12 cubes, which is also an even number. So that pattern is true for all 3 arrays. Each array also, one final pattern to notice, is that each array adds 1 row. Remember, rows are horizontal, columns go up and down vertically, and each array adds 1 row and 1 column. Okay, so if we here's our 1 by 2 array, and when we went to form the 2 by 3 array, it added 1 row here on the top, and making it 2 rows tall, and then it added 1 more column, because right here you have 2 columns, and then it added a 3rd column. And it happens again here. In this array you had 3 columns, so we added 1/4 column there. You had 3 rows, or 2 rows here, excuse me, and we added a 3rd row here. So 3 patterns that we noticed here. These 3 arrays are models for the first 3 rectangular numbers. Rectangular numbers, and this is important for your lesson, your journal page really is going to check your understanding of this here. Rectangular numbers are numbers that can be represented by rectangular arrays. Hence why here, these are models for the first 3 rectangular numbers. Okay? So the first rectangular number would be 2, because I can make that rectangular array with 2 by making a 1 by 2 array. The second rectangular number here would be 6, because I can make a rectangular array, which is a 2 by 3. And then we have 12. We can make that rectangular array a 3 by 4. In each successive rectangular number, the number of rows and columns increases by 1, like we just said in that 3rd pattern we noticed. So again, rectangular numbers are numbers that can be represented by rectangular arrays. So now moving on to introducing you to rectangular numbers, okay? Remember, to do so, we're actually going to connect it to our knowledge of square numbers that we've learned about earlier this year. Remember that square numbers can also be modeled as shapes. What are the first 5 square numbers? Okay, if you think about square number, it's a product of a counting number and the next counting number. That's a rectangular number, excuse me. But for square number here, square number is the product of a counting number with itself. For example, 25 is a square number because 25 equals 5 times 5. Okay, so when we think of the first 5 square numbers, I want you to pause and see if you can figure out what those are. Hint, hint, down here. Okay, hopefully you've jotted down on your scrap piece of paper the first 5 square numbers. And if you had 1, 4, 9, 16, and 25, you are correct. If we think about it, 1 times 1 equals 1. If you took 1, you would make a square array. 2 times 2, any number times itself, they're giving us 4. 4 is our square number. We could make a 2 by 2 array. 9 is another square number. We can make a 3 by 3 array and it would form the shape of a square, giving us the square number 9. 16, 4 times 4 equals 16, and 5 times 5 equals 25, like is shown over here is a 4 by 4. It's showing that 16 is a square number. And they give you the example here, 25, because of 5 times 5 is 25. So what rule can we use to find any square number? Well, that rule is multiply a number by itself. And like I said here, for example, 4 times 4 is 16, and 16 is a square number. It can be modeled by making a square array, shown right here. Okay, so why are we talking about square numbers? Well, because rectangular numbers compared to square numbers, they have some things in common. Both numbers can be formed using shapes when making an array. So what patterns do we see in this list of square numbers? 1, 4, 9, 16, 25. Right now hit pause and I want you to think about any patterns you see in this list of square numbers. If you notice that they alternate, the total number of blocks or cubes in the arrays alternate between even and odd, you are correct. We have 1, which is odd, and then even 4, odd 9, even 16, and odd 25. Each square number increases by the next odd number, because 1 here, the next square number is 4, it increases by 3. What's the next odd number after 3? 5, okay? 4 plus 5 equals 9. So the next square number here did increase by the next odd number of 5. 16 shows an increase of 7 from 9. 9 plus 7 equals 16, and 16 plus 9 equals 25. So that's why that second pattern there is true as well. Just like square numbers, rectangular numbers can be generated or found by using a rule, and many different patterns can be observed. So in part 2 of this lesson, the second video, we're going to explore the rule for generating rectangular numbers. So I'm going to stop right here and I'll start back up on part 2.